Yes, what's up everyone, Homemade Madness, welcome back, and you're watching Homemade Massive CNC Build Part 2. Let's go! So in case you haven't seen Part 1 yet, I'll get you up to speed. So basically, I'm building a massive DIY CNC machine which can both cut wood and steel in large format of 4 by 8 feet. And I want to build the machine right here in this workshop, all by myself, using only the kind of limited amount of machines I have in this workshop, which means, well, I have to get a bit creative sometimes. And for this machine to cut metal, especially steel, in this large working format, it needs to be extremely heavy and rigid. So I designed this huge frame out of massive square box section with the gantry riding on top of this box section and on there the actual milling head. And in part 1 of this project I already built this frame and then filled the entire thing with concrete to make it even more heavy and solid, mainly to dampen vibrations caused by cutting steel. And then to flatten the top surface on which this gantry will ride, I poured a layer of self-leveling epoxy which turned out super flat. So if you want to see more of that, make sure to check out part 1. But in this part 2 I want to make all the moving parts of this machine. So basically the gantry with on there the X-axis and on there the Z-axis for the up and down movement. So when I was designing all of these parts I had to use some other strategies than when I was designing the frame. You see with the frame it was basically the heavier the better. More weight means less vibrations and well, that's about it. But with the gantry that's a little bit different, mainly of course because it will be moving and it'll have to be able to accelerate and decelerate really quickly. So to help do this I already got some really powerful motors to actually move it back and forth. But still I need to keep it as light as possible but also as strong as possible to withstand the massive forces when I'm cutting steel. So to design this gantry I first started looking at what forces it would be encountering. And looking at the milling head we have basically 3 main forces acting on the gantry. First one of course is up and down. Down from gravity but up from cutting forces, for instance when I'm plunging down into a part. And then we have the side to side movement. This one causes the least of my worries and that's down to the entire design of the frame and the machine. The height of the gantry actually doesn't come from 2 pieces of sheet on both sides as you would normally see on a gantry machine, but instead it comes from the frame. The linear rails are on top of the frame, the bed's on the bottom, making it very rigid, while also helping to keep dust and coolant in, and having the rails higher up means they will be less exposed to dust. So side to side it should be plenty strong, but then there's the third force, which is front and back are basically a torsion moment on the entire gantry. So when cutting like this you don't only get a force trying to bend the gantry like this, but also a torsion force since the cutting head is all the way down here and it will try to twist the gantry. And this force only gets bigger when I'm cutting something down close to the table, because of course the Z-axis gets longer and it gives more leverage. So anyways, with all of this in mind I designed this. Basically a massive piece of box section made up out of sheet metal with a lot of triangles cut out on the sides to save weight, and with smaller pieces of box section in all 4 corners where most of the force is going to be. And this will help make the entire thing way stronger, kind of like the flanges on an I-beam. Most of the material on the outsides with a smaller piece of material spacing them apart. And to counteract the torsion force on the gantry, the main box section is then filled with smaller gussets of sheet metal, and adding in this in a piece of box section really helps to keep it from twisting. And then to make it even stronger, also diagonal piece of sheet metal in a triangular shape like this. And with so many triangles in there, well, it almost looks like the Eiffel Tower. But it should give a crazy stiff and still kind of lightweight result. And that's exactly what we need. And then of course on the gantry we have the X-axis looking like this. And on there the Z-axis moving up and down like this. Pretty straightforward. So with all of that sorted, I think it's time to start building. But before we can start building this gantry, first we need to mount the linear rails on the frame. So let's start with that. Oh yes, that's nice. Okay, so these are the 2 linear rails which will mount on the frame and which the gantry will slide on. And they are HDR 35mm ones, or in other words, massive ones. Super sturdy. The carriage will slide on there with absolutely no play whatsoever. And they are 3 meters long, which is as long as the frame is. And they were actually pretty hard to get at first. So I've been looking on all these Chinese sites, AliExpress, Amazon, you call it. But nobody had these, especially in these long lengths, which I need. You can join them, but it's not ideal. So I wanted to get them in full length. And then I just found a local national Dutch company which makes these. They were actually cheaper than the ones in China, partly because of the shipping, but also because they're just so hard to find in China. So anyways, these 2 plus 4 carriages cost me about $1,000. which is not too bad if you think about what it is. They're absolutely vital for making this project work, so super glad with them. Now let's put them on the frame. First I'm gonna do this side only, then I'm gonna make the entire gantry and then use the gantry to align the other side and make sure it's parallel to this one. I figured that would be the best and most accurate way to do it. Of course they have to be perfectly parallel, perfectly straight as well. So I'm gonna make sure they are. So I'm gonna mount them on this epoxy surface and then drill and tap them into the steel frame. And as you might remember from last video, I actually filled this entire steel frame with concrete. So you might be wondering how I'm going to drill and tap into this without, you know, hitting the concrete and blunting my drill and tap and stuff. But I actually thought about this and I mounted a bit of wood on the inside of the steel frame. So there should be no concrete directly under the epoxy, and I can tap and drill into the wood and of course the steel. So that's the plan. Let's get it done. So these rails might look pretty straight, but on closer inspection I found they're actually not perfect. Just putting a straight edge on there, as you can see I can slip a piece of paper between here, but luckily I can also put a piece of paper between the epoxy and the rails at the end here, which does prove my epoxy surface is straight, and once the rails bolted down everything will be flat again. Oh man, this is gonna take a while. And now to get the rail straight in the side to side direction, with the one side bolted down, as you can see there's still a lot of flex in there, which means I can't just bolt it down as it is. So I put my straight edge against there and made sure everything is nice and clean. Then turned off the lights, and with the flashlight underneath there I could clearly see where the gaps were and adjust the rail accordingly. And then I just kept going until I didn't see any light anymore and turned out great. Okay, so that's the first massive linear rail mounted. I mounted it as straight as possible using this precision ground straight edge, and I'm pretty sure I got it, well, pretty much perfect. And then of course also I need to adjust the height, which I didn't do because it's already perfect because of the epoxy. Just putting the straight edge on there, and the water level you can see it is just perfect, which is insane because this is a 0.02 millimeters per meter water level, so insanely accurate. So it's actually way better than I was expecting, and that's awesome. So now I want to put the carriage on there just to see how it rolls. And then we're gonna start work on this massive gantry. Okay, so this is my CNC plasma table. It is absolutely my favorite tool in the shop by far. And the best thing about it, it's homemade. Built it about 6 months ago and made a video about it too. And if you're interested, I have plans for sale for this machine, so you can build it yourself. It's amazing, an absolute game changer, and I've used it in every single video project ever since I built it. But also to do a lot of other stuff like making signs, cutting steel for other people. So anyways, let's use it to make parts for the new CNC machine, which hopefully will be my next favorite machine in the shop. Okay, got all my pieces cut. This is 6mm or 1/4 inch steel, and the CNC plasma cut through it like butter. And I also cut this 50mm square box section, and this will go on the corners of these sheets like this. And then these pieces will go against here to create like a really big kind of square rectangular box profile section. And then of course most of the stress will be in the corners. That's why in the corners, in the bottom and the top, there are extra box sections to make it even stiffer, and that will give us a really strong, super stiff profile. And it's still gonna be relatively light. Well, actually it's still gonna weigh a ton, but doesn't really matter. Of course I've got some really strong motors to push it on linear rails, so I'm not too worried about it. I just need it to be super strong, because don't forget, I want this machine to be able to mill steel. Well, anyways, that's the plan. So weld all of this together, cut some more gussets and weld them in here. Then put it all on the frame of the CNC and see if it moves. So with the main construction of the gantry done, it's time to add these kinda weird looking sticking out pieces of sheet metal. And you're probably wondering why I would design it to be like this. Well, the thing is, I had to find a way to keep the dust and chips and coolant from hitting my precious ball screw and linear rails. So the way I designed this was to make a sheet metal cover going over them like this. And that meant the main construction of the gantry had to stop before it went over the linear rails. And then I can cover the actual gap left with some of this brush material. And you can also use this kind of bellow or some sheet metal to cover the rails. But with the gantry with over 2.5 meters of travel, that just takes up a lot of space and gets really complicated to make. So that's why I made them this way. And I did put a lot of thought into this. And to keep the stiffness, these parts have to be made of fairly thick metal, in fact too thick for my CNC plasma to cut. So I'm gonna have to make them old school. Oh, well, here we go. So with those two pieces on there, the gantry is almost done. All we need is these two big side pieces, which will be cut from this 1/2 inch 12mm steel plate, which is very heavy. Oops. Okay, the gantry frame is finally almost done and I think it looks amazing. Definitely pretty heavy duty. And it's both pretty heavy and then again, for what it is, not that heavy. Probably about 100 kg. So yeah, I'm not too worried about the weight just yet. Of course, this will be moving pretty fast from side to side. And when the router needs to make a 90-degree turn, it'll have to stop really quickly or accelerate really quickly. Anyways, it's still only tacked together and I'll stitch weld it later, not fully welded, just to keep the tension in the material low. A few little welds here and there, spread over the entire gantry. And this way I don't put too much heat into one spot and cause a lot of stress in that spot, but gradually heat the entire gantry, and that way it won't have a lot of stress. So the linear rails for the X movement will mount to this surface. And as you can imagine, it's currently not perfectly flat. But I have a plan for that. Wait and you shall see. Anyways, next up I'm gonna mount this on the frame temporarily so I can mount the second big linear rail and move the gantry around, see how it looks. Okay, first time moving the gantry. Nice. And now using this gantry to perfectly align the second linear rail to the first one, and then drilling and tapping and bolting it in place, and then move the gantry a little bit and do it again. Okay, so the gantry is on there, it's moving very nice and smooth. I mounted that rail parallel to this one using the gantry, and now it's time to take it off again, weld it, and then I'll show you how I plan to fully flatten this surface and make it parallel so we can mount the rails for the X-axis. Okay, so that's it for the welding of the gantry. It actually took me quite a long time, about 2 hours or so to weld all of it. Just so many seams, so many little spots where I missed the weld, and then I rotated it again and saw another spot where I needed to weld, and then again and again and again. And I really had to stop myself from trying to make the weld beads too long. I just need little tag welds everywhere. But you know, once you're going, you want to keep going. But there's no need to do that because the strength really doesn't come from the welds. They just need to hold everything together. The strength really comes just from the geometry and the shapes and all of the pieces. Anyways, next job is to mount the two linear rails on here to make the X-axis. And you might think this surface looks pretty flat, but actually it just isn't. And that's partly because of the welding, but also just the assembly wasn't perfect. It doesn't need to be because I have a plan to make it flat. So what I'm going to do is flatten this surface the same way I did as with the main frame of the CNC, which is by using a self-leveling epoxy. So first I'm going to make sure this is nice and level on the table. Then I'm going to clean this surface and rough it up a little bit so the epoxy will stick to it. Then make basically a mold with 2 bridges going from side to side so the epoxy can flow in the mold but also from side to side. Heat up the epoxy, make it nice and liquid before pouring it in the mold, and then leave it for a couple of days and it will cure basically perfectly flat. Then we can turn it upright, mount the linear rails, and we will have them level, flat and parallel like this. So I'm going to get some wood, cover it with duct tape so the epoxy won't stick to it, and then make this mold. Okay, a couple of days later, the epoxy is nice and hard and it also seems nice and flat, which is good. So next job is to mount the linear rails on the epoxy, then place the entire gantry back on the frame, mount it in place so it's nice and square, level and straight, and then we can finally start work on the Z-axis. Whoops, almost forgot. Of course I need to put the carriages on there first, because I can't put them on after. Okay, so after having spent a nice amount of quality time with the dial indicator and the straight edge, I now get the rails on here pretty much perfect, nice and straight, parallel. So next up it's time to mount the gantry on the frame, and to do that, well, I've got a bit of a special technique. Of course, it's very important the gantry is mounted perfectly vertical, so the spindle will move up and down straight, and of course also square to the rest of the frame, so the spindle will cut nice and square parts for me. So to do that, of course, the best way would be to make sure the mounting flanges of the gantry are square to this surface, so it will mount square on the frame. But in reality that turns out to be pretty much impossible without milling them down afterwards, which is what you would normally do if you want to make something this precise. But I found a way to mount it myself without using a bigger mill. So what I'm going to do is use metallized epoxy and fill the gaps with this stuff. So this is basically just normal epoxy mixed with aluminum powder and iron powder, and it makes a super strong and kind of gooey mix into which I can fill the gaps after perfectly setting the gantry. So to adjust the gantry, I've tapped some threaded holes in here into which I can put a bolt to level it and make it square. And of course after that I'll fill up the gaps with the epoxy stuff, let it cure for a couple of days, and then we will have a perfect surface, flat and level, exactly how we want it without using any complicated big machinery. So that's the plan. Let's get on with it. So to start off, I'm covering the surfaces I don't want the epoxy to stick to with some duct tape, which are the carriages and of course the rails. And then I mixed up the epoxy according to a special recipe I found online, which consists of course the epoxy resin, the steel powder, the aluminum powder, and then some fumed silica to get the consistency right, so it's nice and gooey like this. And what you then get is basically a DIY version of JB Weld, but in some bigger quantities and much cheaper. And as you might know, that kind of stuff is super hard and will cure pretty much as hard as steel. So with the gantry on there, my first order of business was to get it square to the existing linear rails of the frame, using the straight edge combined with the biggest machine square I could find. And I can always slightly tweak this squareness later on by adjusting the homing position of each of the two Y-axis motors, but it's best to mount it as square as possible in this stage. And once I had it square, I could start working on getting it level left to right, with the straight edge on the linear rails of the frame, and then adjusting the height of each side with these two grub screws. And then finally checking if the plane of the rails is vertical by putting the machine square to it and then putting the high precision water level on top of that. And again adjusting the grub screws to dial everything in. So getting everything aligned actually took quite a while. But you know, the epoxy is slow curing, so I just took my time to make sure everything is perfect. Okay, so it's about 2 days later now. The epoxy should be nice and cured. And as you can see, the gantry moves freely along the entire track, which is quite a good indication the rails are parallel. There is no binding anywhere, so that's nice. And also it's still square and level. And I'm pleasantly surprised about how good this method actually works. I had a nice amount of time to fiddle around with the set screws. So now it runs nice and smooth. It is pretty heavy though. So next up I want to make the Z-axis assembly, which will go of course on these rails. So for that it's to the welding table. So I've already been doing some cutting on the plasma table, and this is what we have. This is all 12mm or 1/2 inch steel. This will be the side pieces. This will be the top plate to which the motor will mount in these slots. And then we have the back plate. So I'm going to drill some holes and weld it together. And here you can see just how strong and tight these linear rails really are. And there's almost no play or deflection. Most of what you see here is just the sheet itself bending. And this here is a pretty good indication everything is still properly aligned. Just slipping by it, nice. And then the reason why I even mounted this sheet on here in the first place, which is to transfer the hole locations using the center punch with some tape around it to fit snugly in the holes. Okay, so that's the Z-axis carriage all welded together. Nice and heavy and solid. And also I've been drilling some holes in the back here to mount the carriages, to mount the actual vertical moving Z-axis too. So when you're talking about Z-axis, there are basically two designs. One with the carriages stationary and one with the rail stationary. And both ways have their pros and cons. Usually with the carriages mounted stationary and the rails moving up and down, you get a bit more rigidity, which is good for cutting steel. But with the rail stationary and the carriages moving up and down, you get a bit more Z travel and more Z clearance. So it's kind of a trade-off, but I've opted to go with this design. Also because when the spindle moves up higher, it comes closer to the carriages, making it more rigid. So my thinking is, when I'm milling a piece of metal or steel on this machine, it's usually in a vise or in a chuck, meaning it's also lifted off of the table. And with this design I'm going with the carriages mounted and the rails moving up and down, the spindle tends to get more rigidity when it goes higher. So that means when I'm milling metal on a vise, it's more rigid than when I'm milling something like wood, which is normally closer to the table. So that's kind of why I chose this way to do it, more rigidity. So anyways, this is now done, but before I can mount it on the gantry, I first need to mount the carriages, because the carriages have to bolt in from the rear here with some countersunk bolts, which I can't reach anymore once it's mounted on the gantry. But of course I need to mount them on here parallel to each other. And to do that, well, I first need to make this assembly with the two linear rails on there, which will be perfectly parallel, and then they can guide the two carriages into place and I can bolt them wherever they want to go. So already cut out some 1/2 inch 12mm steel again, and this will be used to make the Z-axis, which will go up and down and hold the actual spindle. So let's weld it together, mount the linear rails on here parallel to each other, use that to align the bearing blocks on here, and then mount it all on the gantry, see what it looks like. That's the first rail mounted. Now for the second one. So time for the dial indicator. Okay, so that wraps up this video, part 2 of the monster CNC build. Made a gantry, mounted all the axes, everything moves nice and smoothly. And originally I want to get some more stuff done in this part 2 video of this build series. But I think this video is already growing pretty long, so I'm gonna end it here. But I'm still super pleased with what I got done. Everything is moving nicely. It should be perfectly aligned and still square and stuff. And it's definitely heavy duty, which is a good thing. So in part 3 of this build project, I'm gonna mount the ball screws. As you can see, I've already mounted it for the X-axis and done some prep work for the Y-axis. These ball screws are huge, 32 millimeters. And after that, mount all the servo motors and hope we can get some movement. But before we can do that, of course, we first need to wire them. So I'm gonna make an electrical box, show you how to do that. All the components. Then we're gonna make some direct chain to get the power to the actual motors on the moving bits. Make some covers for this stuff. Also I want to make the flood coolant collection system, basically a big funnel to collect all the coolant and pump it back to the spindle. So by the end of that video we should have a moving machine and maybe can make some first cuts. So I'm pretty excited for that, and honestly I can't wait to have this thing done because I have so many cool ideas on things I want to build with it. But that's gonna have to wait until it's done. So I better continue with building and I hope to see you in the next part.